Hi everybody, today we're going to talk about Newton's laws of motion. By the end of this, students will be able to recite Newton's 3 laws of motion and answer some questions about them. So the first law of motion is also called the law of inertia, and it states that an object of motion will stay in motion and an object at rest will stay at rest unless acted on by an unbalanced force, or outside force, or some type of force, depending on what source you use to look up the definition of the first law. You might get a different word there. But basically it means something from outside the system that the object's in. This means that objects will keep doing whatever they were originally doing until something changes that. So the only thing that will make something change its motion is a force from outside that object. So let's do an example. It says a space probe is moving through distant outer space at a speed of 200 meters per second when it runs out of fuel. What happens to its velocity? So the options are it speeds up, it slows down, it changes direction, or it doesn't change its velocity at all. So Newton's first law says that things will keep doing whatever they were doing. Out in distant outer space, there's nothing there to act on it. So if you're saying that it slows down, that would be wrong, because there's nothing in space to slow it down. What's really going to happen, it's just going to keep going at the same speed. It's going to maintain constant velocity until something gets in the way. The second law of motion says that the acceleration of an object is directly proportional, more on that word, those words right there in a second, to the force acting on it and inversely proportional to its mass. So there's two phrases, directly proportional and inversely proportional. A direct proportionality means usually that there's a linear relationship between the two. Like if you increase the force acting on something, then it'll accelerate more. Inversely is the other way around. If you increase the mass of an object, then its acceleration will decrease. And this kind of makes sense. Heavier objects are harder to move than lighter ones. And if you push on something more, you'd expect it to move more. Or in other words, the more force acting on it, the more it accelerates, and the more mass it has, the less it will accelerate. I think this one's kind of common sense. So for example, let's say the force acting on an object is tripled. By what factor will its acceleration increase? If you said the acceleration would also triple, that's actually correct. A direct proportionality means if you double one, you double the other. If you triple one, you triple the other, and so on. There's an equation for Newton's second law. It's F equals ma, and that funky letter in front of the F is Greek letter capital sigma, and it stands for total or net, depending on the way the question's phrased usually. So sigma F means net force or total force. M stands for mass, which is measured in kilograms, and A is acceleration, measured in meters per second squared like it has been all year. The third law states that for every force or action, there's an equal and opposite reaction force. It's important that this says and, not or. Some people like to say or there, and that's not correct. This means if you push on something, technically it pushes back on you with the same amount of force. This is probably the weirdest of the three laws because it's kind of strange to think about it this way. So for example, let's say all of the following situations can be explained using Newton's third law except for one of them. Which one cannot be explained using third law ideas? A says an inflated balloon is not tied and it's just let go, and it moves forward as it pushes air backward out of the hole in the balloon. B says the gravitational interaction between the Earth and the Moon affects both objects, with Earth's tides mostly due to the Moon's gravitational pull. C says a projectile's horizontal velocity remains constant because gravity is a vertical force and no horizontal force acts on the projectile. And D, a propeller airplane would not work in outer space because propellers work by pushing air backwards to move the airplane forward. Out of all these options, A can't be it. I mean, you have the balloon moving one way and pushing air out the other way. That's like equal and opposite forces. B can't be it because this does happen. This is what causes tides on Earth. The moon's gravity pulls on the Earth. The Earth's gravity keeps the moon in orbit. They work together. It can't be D because this is actually true. Propeller airplanes work by the propellers pushing air backwards, so the plane moves forwards. That leaves C. So since its horizontal velocity is constant and gravity is up and down, I mean, that's true. It's not like C is a false statement. It's just not something that deals with Newton's third law.